Of the topic called integration that we have been dealing with. In the first video, we talked about integration formulas, some basic integrations formula that you need to know when you are given an integral, how to change it to integration, how to get the final answer. So on this first class, we deal with how to integrate algebraic functions, just a straight direct algebraic functions in which you can just apply the integration formula to solve directly without stressing or wasting your time. But this one, there are some integrations or there are some integral that you'll be asked to integrate that applying the integration formula directly will not work. Yeah, so that is why we are going into this lesson 2 for you to learn more and then know more on how to solve integral questions that involve that is not direct integration, in which you must know the method to use. And when dealing with integrations, apart from the one that will be straightforward, that you will be able to integrate directly, we have some integration methods. And these methods are substitution method, partial fraction, and integration by part. So now it lies in your hands on how to determine or how to know the right approach when to apply this integration method. So, well, in this class, we focus more on the substitution method. So, actually, we are going to cover the second method and the third method and the later in the future. So, but we focus deep on what? On this substitution method. And so, because there are some integration that you cannot just integrate, like this note said, this kind of integral f of x is being integrated by substituting it by letter, because the function most of the time do not conform with the standard integration formula provided at the previous video. So this method of integration, like I mentioned, will be using in solving these integration questions. And this method are substitution method, partial fraction, and integration part. So for now, actually, like I said, we focus on substitution method. So when can you apply substitution method? This is when you are dealing with composite function. You will understand what is meant by composite function. Product, quotient of two expressions having non-fractional power, and product or quotient of two expression having fractional power. So what do you understand by product? That is when you are multiplying when you have two different functions. So you get now multiplying two different functions, and that quotient simply means when you have fraction of two different functions together. When you have these, and the composite function is maybe you're having function of a function. So all this, when you encounter all this, the first thing that's supposed to come to your mind is what? Is substitution method. So you are going to use substitution method when you have this kind of challenge, when you are doing integral questions for you to integrate. So now, the rules also, it has its own rule. That is, the rules you must follow when you want to apply substitution method. The first thing is that you substitute part of the expression containing radicals, fractional powers, integral power, or complex parts with any with any arbitrary letters, such as, it can be any letters. So you can use A, you can use B, you can use W, you can use any alphabetical letters you wish to use. Yeah. And the second one is provided that the integral function, that is the rational function, you understand, given is not in partial fraction, then that is, you must also know that is this kind of that do occurs when you are dealing with quotient functions. Yeah, you must know that is this kind of function not what? I mean, I'm referring to algebraic function now. Actually, is it not partial fraction? So once you determine that it's not partial fraction, actually in partial fraction too, you are still going to apply substitution method, but there are some things you need to do. You need to solve it in a partial fraction format before applying substitution method. So that is why you must know this one. You apply substitution method directly, but in partial fraction you need to solve the integral question given in partial fraction method before before now using substitution method. So like I said, so you are going to use letter to represent them. So provide the integral function rational, so with arbitrary. Then after solving, so after substituting, differentiating and getting the final answer, the u is going to be returned back to the initial what integral function. So and you are going to understand all this explanation as I'm giving you right now. So let's solve some examples. So example 1 say that what evaluate integral of what 2x plus 3 or everything raised to what power 5 dx. So you can actually see that this kind of function is called what? It's called function of function. This is composite function actually, in which 2x plus 3 is being infused in a particular function which is like x raised to power 5. So that is why it is called composite function. So you get now. So this kind of integral fx which equals to 2x plus 3 can only be integrated by what? By using substitution method. So reasons cannot be solved by normal integration. You can never solve it by normal integration formula. You won't get the answer. Not that you won't apply the normal integration, but you know, life is just like life entails stages. So you need to reach some stage before what? Before you can apply the what? Integration formula. So the second thing which I've said before is what? The function is a composite function of power 5. So solution now, step 1, substitute. We've already started what? Using substitution method now. So the first step is that what? After you've discovered that it's a composite function, then you substitute that integral with what? With any letters. That is step 1. So step 1 says that substitute u for f of x. So let u equals f of x, and f of x is what? 2x plus 3. So the second method is what? You differentiate with respect to x. You differentiate that u with what? With respect to x. So differentiate u with respect to x. We have what? The u dx equals to 2. You cannot run away from differentiation. So if you don't have the basic idea of differentiation now, it's better you go back to it. Don't worry, you will try to do some differentiation too in the future. So but let's focus on the integration. So the u dx equals what? 2. So that means the u dx, from this one you can see that it's implied that the u over 2 equals what? The x. So step 3, replace f of x with u inside that integral, and then the x with what? The u over 2. So there's no fluke there, there's no magic there. So it's just normal mathematics word. So the integral u raised to power 5 all over what? The u over 2 equals what? Integral u raised to power 5 over 2 du. We've substituted the necessary data we need to replace with each other. So which equals to 1 over 2 integral u raised to power 5 du. So eventually now we've applied the integration formula, the basic formula you've been taught in the first video. So which is equal to what? 1 over 2 all raised to the power what? U raised to power 5 plus 1 over 5 plus 1 plus c. So 1 over 2 into bracket u raised to power 5 plus 1 all over 5 plus 1 close bracket plus c, which will eventually be what? 1 over 2 open bracket u raised to power 6 divided by 6 close bracket plus c. So which is now what? U raised to power 6, that is 2 multiplied by 6 at the denominator plus c. So after that, with the final answer, the semi-final answer, let me put it that way, is what? Is u raised to power 6 all over 12 plus c. So record that, yeah, because you should not forget that you are going to return u back to the actual integral function you are replacing u with. So record that u is equal to what? 2x plus 3. Then you can now replace u with what? 2x plus 3. Then our final answer is now what? Parentheses into parentheses 2x plus 3 all raised to power 6 all over 12 plus what? Plus c. That is the final answer for that example 2 given. That is what? Final answer for that example 1 given. So we go to example 2. Evaluate integral of square root of 2 minus 5x dx. This kind of function too is a composite function. Shows that the first function is what? Is 2 minus 5x, which is being infused inside function of like x square root of x. Sure again now. So that is why it's a composite function. It's a function of function. So we substitute the function of what? The integral of 2 minus 5x inside the radical function, which is what? Which is a radical function, like being said, that is square root of 2 minus 5x with u. So u is equal to 2 minus 5x. Yeah. So then we differentiate u with respect to x. That is the u over the x equal to minus 5, which implies that the x is equal to what? Minus u over 5. Recall that the radical function, parenthesis, square root of 2 minus 5x can be written as what? Square root of u via what? Substitution. Yeah. So which means square root of u equals what? U raised to power half. That is from law of indices. So thus via substitution we have what? Integral of u raised to power half multiplied by minus z u 5, like what we did in the first example. It's just, you can go through the first example, it's just the same steps. So, and you bring out what? You bring out the constant. The constant is minus 1 over 5. That is why you see that minus 5 is outside the integral symbol. So which is equal to what? U raised to power what? Minus 1 over 5 integral u raised to power half du. So recall your n is 1 over 2 from the basic idea of your integration formula. Therefore, you simplify, you solve it. So we have what? Equals minus 1 over 5. Or parenthesis 0 raised to power half plus 1 plus 1 over half plus 1 plus c. So minus 1 over 5 parenthesis u raised to power 1 plus 2 over 2 all over 1 plus 2 over 2 open close bracket plus c. So minus 1 over 5 all into bracket u raised to power 3 over 2 divided by 3 over 2 close bracket plus c. So you can see that minus 1 over 5 eventually square bracket u raised to power 3 over 2 divided by 3 over 2 close bracket plus c. So minus 1 over 5 square bracket u raised to power half plus 2 over 3 close square bracket. So minus, and eventually we have what? Minus 1 over 5 multiplied by 2 over 3 parentheses square bracket u raised to power 3 plus 2 plus c. So you can see then the final one, you replace your u with your former integral integrand. So that is 2 minus 5x. So our final answer equals what? It's equal to minus 2 over 15 square brackets parentheses 2 minus 5x close 3 raised to power 2 close square bracket plus c. So that is the answer for what? For example 2. So we go to example 3. So you have to evaluate integral of 7 all over what? 5x minus 4 all raised to power 5 ds. This kind of function is actually called what? It's actually called, you can call it composite function, and you can call it quotient function because it's in the form of fraction. So I said composite function because that 1 over of that function f(x) minus 4 raised to power 5 can actually be changed to raised to power 5 minus 5 rather, from your knowledge of indices. So all the same. So now you bring out the constant, which is what? 7. So you bring out the constant 7. That was why you can see 7 outside the next line. So 7 integral of 1 parentheses 1 over 5x minus 4 raised to power 5 ds. So like we've been doing, let u equals 5x minus 4. So you differentiate with respect to x, you differentiate the u with respect to x. So you have the u over 5 equals the x. So 7 integral of 1 over u5 multiplied by the u5. So from the basic, you can't run away from that basic integration formula. You will be applying it every time, often. So you know that 5(2) after the substitution of a term, you can bring it out 1 over 5 because it's a constant. So that's why you have 7 over 5 integral of parentheses u raised to power minus 1 close 5. You know, we got that raised to power minus 1 from the law of indices, like I said before, multiplied by du. So which eventually result to equals 7 minus 7 over 5 integral of u minus 5 times du. So this you can easily integrate them. Yeah, you can use normal integration formula to integrate it, because it's just simple. It's just basic integration question. So after applying it, we eventually result to what? Our answer equals 7/5 parentheses u raised to power minus 4 all over minus 4 plus c. So like we always do, replace 5/x minus 4. So anywhere you see u, you write minus 5x minus 4. Thus our final answer is now what? You can see from here, we derive at 7 multiplied by 5 multiplied by minus 1/4. You know, we just bring out the minus, the denominator minus 4. I will multiply how can I put it, the constant with each other. So thus we have minus 7 all over 20 into parentheses 1 all over 5x minus 4 all raised to power 4 plus c. So there's no fluke there, there's no much magic in there. Just understand the necessary steps. So the same thing goes to example 4. Example 4, I try to solve lots of examples for you to have deep knowledge, deep understanding regarding integral question when you involve using substitution method. So at least that's like all those examples here, we help you to be able to tackle at least some question regarding integration questions that you must apply substitution method for. That is not straightforward integral question. So evaluate integral 3x all over what? Square root of x raised to power 2 plus 1 dx. You can see that this kind of question is typical what? Is typical composite question and what? Quotient fraction. Sure you get now? Because you have 3x at the top and there. So how can you do this? So you work with the one with the higher power. So let u equals what? S raised to power 2 plus 1. Then you differentiate like we always do. So du equals to what? 2s dx. So, and which implies that what? Du over 2 equals x dx. Yeah, you'll be wondering why we are separating the u over 2 from x dx. Yeah, we will soon realize the reason why. So therefore equals what? Integral 3 all over the square root of s squared plus 1 x dx, which implies that what? 3 all over u plus multiplied by du over 2. So you bring out the constant. So that is why we are having what? Equals 3 all over 2 integral 1 all over square root of u du. So you apply the basic integration. So you have what? That implies that 3 all over 2 from your knowledge of indices, integral square root of u raised to power minus 1 du. Then you what? You integrate. So after integration, so you can see from here, so eventually still from the basic knowledge of law of indices, we have equals to 3 over 2 integral of u raised to power minus half du. That is gotten from here, from this particular region here, you can see. So which eventually we have for 3 all over 2, we simplify the integral, which is equal to 3 all over 2 into parentheses what? U raised to power minus half plus 1 all over minus half plus 1 plus the constant c. So which eventually results to what? 3 all over 2 to parentheses u raised to power minus 1 plus 2 all over 2 all over minus 1 plus 2 all over 2 plus c. So you have 3 all over 2 into parentheses u raised to power half all over half plus c. So you collect the like terms, actually you multiply the constant number by each other. So 3 all over 2 divided by 1 over 2, which we eventually have 3 all over 2 multiplied by 2 over 1 from your knowledge of your division and multiplication. So multiply by u raised to power plus c. So we eventually have 2 into parentheses u raised to power plus c. So recall that u equals what? S squared plus 1. So you replace u with s squared plus 1. So thus we have 3 into bracket parentheses s squared plus 1 raised to power half plus c. So you recall half is square root. So we now return it back, which is equal to 2 square root of what? S raised to power 2 plus 1 plus what? Plus the constant. That is the solution for the what? For the example 4. for the example 4. So example 5, the same thing. You can just go through the steps. I can't explain everything. So, but I've solved everything. I've expatiated it enough, well explained. So it's something you will actually understand. Look at integrand. So with higher power of s raised to, which is the one with what, s raised to power 3 plus 5. So you differentiate that so that you can replace it with the s square. So because differentiation just means reducing. Do you understand now? Why integration means becoming whole. So you get now. So you focus on the integrand with the function with higher power. So you deal with that higher power via differentiation so that you can replace it with the lesser power, that is s squared. So you can actually see that's what it did here. So you see the u over 3 equals s squared plus, so that we can substitute with everything with the u. So you can see from here we have what. So you can see. So example 6 is also the same thing. The one with the higher power, which is s raised to power 4, compares with the function of s raised to. So we differentiate the one with the higher power, which is s raised to power 4 plus 3x raised to power 3 plus 2x plus 2x. So you differentiate that. So after differentiation, you can see thus we differentiate, we replace that with our u, and we differentiate the u with respect to that s, which we derive at what, 4x raised to power 3 plus n raised to nx raised to power 2 plus 2. So via substitution we have u du. So why is it u du? You can see that your u via differentiation, your du is equal to what? Is equal to 4s cube plus 9s raised to power 2 plus 2. So which will eventually be what? Du all over what? 4x raised to power 3 plus 9x squared plus 2 equals dx. Sorry, that we did not write that, but that is it. Du all over 4x raised to power 3 plus 9x raised to power 2 plus 2 equals dx. So if you replace that one with dx, you call that 4x raised to power 3 plus 9x plus 2 at the numerator. We cancel out the one at the what? Denominator. That was why we eventually resorted towards integral of u du. Share again now. So and you simplify, very simple. So don't be scared by the gigantic number like large power. You know, sometimes you will see something maybe it's too complex, but eventually it's actually simple. So you integrate that u du, and you know how to integrate it. I believe by now you're supposed to be able to know how to integrate it. That is u raised to power what? 1 plus 1 over 1 plus 1 plus c. So you replace that u with the initial integral you are using in place of u. So which is what? S raised to power 4 plus 3s raised to power 3 plus 2s all raised to power 2 plus what? All over 2 plus the constant. So that is the answer for that one. So example 7, the same steps. You focus on what? This is quotient function, in which you focus on the what? The example 6 is a product function. This one is a quotient function. The higher power is what? Is x raised to power 3 plus 3. So you differentiate that higher integral power, higher integral function. So you differentiate it. So and we eventually have, after differentiation, we have du equals 3x raised to power 2 dx. So you make du over 3 equals what? Equals s squared dx. So then you substitute. So that is why you are having what? You can see that replacing du with all the same, replacing du with 3s squared plus dx, we have what? 1 over u du. Then you integrate, and recall the integration of formula of this like I'm just flashing you back to when you want to integrate 1 over x, you have what? Ln x plus c. That was why that integration of 1 over u du also what? Resulted to what? Ln u plus c. Then you replace u with x raised to power 3 plus 3. That is why you're having what? Ln parentheses x raised to power 3 plus 3 plus what? Plus the constant. So example 8. Evaluate s squared plus 1 all over what? S raised to power 3 plus 3s minus 4. The same thing. So you see after the you find the one with the higher power, which is s raised to power 3 plus 3s minus 4. That is the integral function with the higher power. So let u equals what? 3 raised to power x raised to power 3 plus 3s minus 4, which implies that u is equal to what? Via differentiation now, 3s squared plus 3 dx. So you bring out what? So you can see here that u equals what? 3 into bracket s squared plus 1 dx, which is actually what? Du over 3 into what? Which is equal to s squared plus 1 dx. So, and you can see that from this, which implies that integral of 1 over s raised to power 3 plus 3s minus 4 close bracket multiplied by s squared plus 1 dx. Recall that one is actually equals to what? Du over 3. That's why we are saying in the next line that integral 1 over u multiplied by du over 3, which implies that you bring out the constant, which is what? 1 over 3 integral of 1 over u du. And we've done something relating to 1 over u integration, which is going to eventually give you lane u. So that's why we're having 1 over 3 multiplied by lane u plus c, which implies that 1 over 3 lane u plus c. Recall that u equals what? S raised to power 3 plus 3s minus 4. So which is equal to what? 1 over 3 lane. You know that we replace u with what? S raised to power 3 plus 3s minus 4 in the last line for that example, which is 1 over 3 lane s raised to power 3 plus 3s minus 4 plus c. So the last example is this example 9, which asks you to evaluate. It's just the same step, the same principle, the same method. So let u equals what? The one with the higher power. You substitute the integral, the higher integral function with u. So let u equals what? Let u equals what? X squared plus 10s minus 4. So in which apply the u equals what? 2s plus 10 via differentiation, and we solve it, we simplify. So you can see that we are deriving at du equals 2 parentheses 2s plus 10 dx. So du equals what? We bring out 2. We can factorize out 2. That was why we have 2 into parentheses x plus 5 dx. So making s plus 5 parentheses s plus 5 dx the subject of the formula, which is equal to du over 2. So you now derive at what? Now derive at integral s plus 5 x squared all over s squared plus 10s minus 4 dx, which implies that what? You bring out that the one at the numerator, you multiply it, so I will be able to what? Substitute with du over 2. So that is why we have integral parentheses 1 over s squared plus 10s minus 4 multiplied by x plus 5 dx. So which integral is equal to 1 over u multiplied by du minus 2. This implies that when we bring out the constant, that is 1 over 2 integral 1 over u du. So that is why we have what? Basically, whenever you have something like this, integral is going to give you lane of that function. So that is why we have 1 over 2 multiplied by lane u plus c, which implies that what? 1 over 2 lane u plus c. Recall that u is equal to what? S squared plus 10s minus 4, which the final answer is equal to 1 over 2 lane into parentheses s squared plus 10x minus 4 plus c. So you can go through all these examples: example 9, example 8, example 7, example 6, example 5, you can see it, example 4, example 3, example 2, and example 1. You can go through this slide, and then it's when explanatory is everything is being broken into segments, so it's something you actually understand. So if you don't understand, you can just comment if you have any questions to ask, comment in the comment box. But the main thing is, as you watch this video, try to like, subscribe, and God bless you. So the next topic will be focused is still on substitution method. When there are some substitution, there are some algebra function given in which you can't use this let u be no, it's asked some basic rules, and this class is going to take us to what? Substitution method using trigonometric substitution function. So because it will be given in form of like what we are solving now, in form of algebra function, but you use what? You use trigonometry substitution function to what? To solve this kind of thing. So activate for the what? For the next slide. God bless you. Thank you.